Now let's continue with string manipulation functions of the string.h library. The string.h library is also a standard library in C, and we'll talk about multiple categories of functions included in this library. Right now, we'll look at string manipulation functions. This will be followed up by string comparison functions and string search functions. Also some memory functions. And all of these functions that we'll look at are all included in the string.h library. But for now, we'll look at string manipulation functions, specifically copying and concatenating strings, meaning taking two strings and combining them, putting them one after the other. Now, every function that we look at today, except for the string copy function, appends the null character to the result that it produces. Here are the functions for today. There are two versions of string copy. There's string copy. There's string ncopy. For concatenation, there's string cat, short for string concatenation, and string Ncat. So these two pairs of functions have some similarity. Obviously, there are two versions, as you can see. You can see a pattern over here, one with an n in between, one without, and we'll see in a minute what the difference is. So string copy basically can be used to takes two arguments, string s1 and another constant string s2, and it copies string s2 into the array of string s1. Now, the string copy function returns the value of s1, meaning a pointer to the start of s1. And you see that in the return type, it's a character pointer. And in that sense, all four of these functions do the same thing. The product, the output produced, the work produced by these functions is returned in the form of a character pointer, the start of the string that they produce. Let me now talk about this pesky looking n in the function names of two of these functions. So what's the difference between string copy and string ncopy? So string copy simply copies string s2 into string s1's place. String ncopy copies at most n characters of string s2 into s1. And I'm saying at most because if a null character is encountered before n characters have been copied, then that's the end. The null character kind of serves as the terminating character in that case. Then we have the string concatenation function, appends the second argument, string s2, to the end of a character array or string s1. Now we have to make sure that the size of array s1 is large enough to accommodate all the characters coming in from s2. And the string ncat function does the same thing, but it appends at most, as you may have guessed, at most n characters from s2 to the end of string s1. So let's look at a couple of examples. But before we do, there are some Microsoft Visual C++ peculiarities, and it's this: string copy, string cat, string ncopy, string ncat. They all have secure counterparts in Visual Studio. What that means is, in Visual Studio, instead of using string ncopy or string ncat, we'll be using, I think I missed an n over here, we'll be using string ncopy underscore s and string ncat underscore s instead. And the same thing for string copy, we'll be using string copy underscore s in its place. Same thing goes for string ncopy. So all 4 functions have secure versions in Visual Studio, and we'll be using those. I'll show you the examples that we have in the textbook using the regular versions and string.h, but in the hands-on section, I'll be using the secure versions. This time around, there's also another slight difference with these secure versions. They do not return a pointer to the work product, to the first argument that we're passing to these functions, string s1 over here. So we have to make some more changes to the code, and I'll show you that too in the hands-on section. The thing with string ncopy is that string copy and string ncopy is that string ncopy does not necessarily copy the terminating null character of the second argument. This happens only if the number of characters that you're copying are at least one more than the length of the string. So for example, if you have a string test with 4 letters, then the 5th letter, as you by now know, is the terminating null character. So test really requires 5 characters, including the terminating null character. Now, if the third argument is larger than 5, the third argument in the string ncopy function is larger than 5, the null character gets appended. Otherwise, you'll have to take care of that yourself. And we'll do that in our example. Now, in the example that we're going to look at, what we're going to do is this. We'll use string copy to copy the entire string in array X into another array Y. And we'll use string ncopy to copy the first 14 characters of X into another third array Z. And we'll also see this manual addition of the null character at the end of array Z. Okay, so here's the sample program. We are including standard IO, of course, the string.h library, which we are demoing over here. We define 2 symbolic constants, size 1 and size 2. Size 1 is 25, size 2 is 15, and the program is just a main function. We define a character array X and initialize it to this string over here, happy space birthday space 2 space U. And we also define a character array Y, size 1, meaning this is 25 characters in size. And we define a character array Z, which is 15 characters in size. So, first we print out X as it is, which is this entire string, happy birthday to you. And then we print out, array Y after we call string copy y comma x. Meaning, what does string copy y comma x do? What does it do? It copies the string from X into array Y. So it should copy this entire string, happy birthday to you, into Y. This string X is, I think I just counted it, 21 characters. plus the null character, so 22 characters in length. So that's enough. Which means that array y is 25 characters in length, so that's enough to accommodate this message, this string. Shouldn't be a problem. So when we print out the string in array y is, it should give us the whole message, happy birthday to you. Then we call string ncopy. And as you can see, what we do is we want to copy the contents of x into z. Now we already know x is a 22 character message. Z has only a size of only 15 characters, which means we won't be able to fit everything. So we copy only the first size 2 minus 1, meaning 15 minus 1, or 14 characters. The first 14 characters from x into z. And we're leaving the last one untouched for the moment, because we need that to accommodate to add a null character. And we do that on line 23, when we write into the last position, the last element of z, the null character, to make it a properly terminated string. And then we print out whatever we have in string z. And if we run this code, there's no user input here, we should get something like this. So we first print out string x, happy birthday to you. We copy the entire thing into array y, which is not a problem. Array y is big enough. So we print out y after that. We see the whole message, happy birthday to you. Then we copy the first 14 characters into z, which is a smaller array, and add a null character after that. And when we print out z after doing both things, we get happy birthday. Now, I told you that there are some more changes needed when we use Microsoft's secure version of the string copy and string ncopy function. The thing is that the string copy function does not return a pointer to the output array, in this case y. Instead, it returns an error code, which means I can't just write string copy yx in here. It's not as convenient as that. So instead I execute string copy underscore s outside of printf before before the printf statement. Y is updated, and then once I run the printf statement, I print out y. So I'm using two statements, whereas in the example given in your book, we're using a single printf statement to do both things, called string copy and show the new string y. And we do something similar when it comes to the second example. Actually, no, not for the second example. We're already doing string ncopy as a separate statement, adding the null character and just printing it out over here, printing out the string z over here. So no problems with that. So there's a slight change that I have to make, which adds one extra statement to the code. The output will be the same. You'll see in the hands-on section. The other two functions were the string cat and string ncat functions. And so the string cat function appends the string in the second argument to the end of the string in the first argument. What it does as well is it replaces the null character of the first string. It overrides that with the first character of the second string. However, what you still have to do is you must ensure that the first string is large enough to store both the first string and the second string and the terminating null character. In string ncat, it appends only up to a specified number of characters. That's what the n is. the third argument. In this case, you do not have to manually add a null character at the end. String Ncat and string cat, they do that all by themselves. So the terminating null character is automatically appended in here. And here's a sample example program for that. So we define a character array S1, size 20, and we initialize it with the string happy, space. And we have a second character array S2, initialized to new space, year, space. And we have a third character array of size 40, called S3, which contains, well, it's an empty. It's empty. It doesn't contain anything. The first character will be a null character here. So we call the printf statement, and we print out string S1, print out string S2 with a new line character in between and new line character after S2. We then print out the result from string cat. So this will add S2 at the end of S1, meaning S1 at this point entering is happy, space, and S2 is new space, year, space. So after we call string cat with these arguments S1, S2, S1 will be this string over here. Then I also call string Ncat with S3 and S1 and 6 as arguments, meaning I copy the first 6 characters from S1 to the end of S3. And what will that do? Well, at this point, S3 is an empty string. If I copy the first 6 characters of S1, that'll make S3 equal to happy, space, and it'll automatically concatenate, add a null character at the end, right? Because that's what string cat and string ncat do. Finally, I take this string S3 that I have and I concatenate the entire string S1 to its end. And it's size-wise, that's not a problem. Remember, the size of string S3 is 40 characters. That's plenty. And what will that do to S3? S3 will now become, well, at this point, it already contains happy, space, and S1 from up here contains happy, space, new, space, year, space, and that'll include the null character at the end. Now here too, this is how it works in on many platforms, but since we're using Visual Studio, we have to use the secure versions of string cat and string ncat. And again, the same thing, the return value from string cat and string cat secure and string ncat secure, the return value is not over here as the pointer to S1 or over here pointer to S3 or S3 over here. Instead, the return value is an error code, which means we have to add separate statements. We have to add these 3 lines over here. And so we execute the string cat functions. The first argument of the string cat functions, whether it's S1 or S3 or S3 over here, is updated, and then we print out the updated string in the printf statements. So slight change that you have to do when you want to use the secure versions of these functions. And this is what the output's going to look like. Happy space New Year space concatenate S1 and S2, you get Happy New Year. Concatenate S3, S1, where you pick up only 6 characters from S1, you get happy space. And concatenate S3 and S1, you get Happy New Year.